from a different course that I'm running with you. And so basically, this talk, I look at IoT as the future of this. This talk is a bit I wouldn't say dated, because the things I'm talking are very much up to date, but I made a couple of years ago, so it's not from yesterday. And every time I click on the thing. Okay, yeah. Yes, very briefly about myself, super brief introduction. I work at Melbourne University, as you see here. I work in interaction design. I have a PhD in interaction design. And I've been teaching also at the Fine Arts School in Valencia for many years now. And basically, I work with interactive objects, design of new devices, connected devices, and so on. And people know me as well because I'm one of the co-founders of Arduino. Arduino is a platform that we'll talk about right now. And I've been running the research for new projects within this company since a while ago. And on top of my PhD in design, I'm also an engineer in telecommunications. So I actually know quite a bit about embedded technology, radio communications, and microelectronics, which is my specialty in the world of telecommunications. And I think the important thing is to have an understanding of IoT. IoT, as you know, is the acronym for Internet of Things. I'm sorry if it sounds a bit pedantic to say it now, because I think it's a term that everybody knows nowadays in society very much. But what we've seen over the years is there's been an unrealistic promise from companies on how many connected devices we will see. I mean, there is many connected devices in the world. Everybody has one or two mobile phones and several computers that are always connected, but it is not the same kind of IoT we imagined years ago. So it's a different type of IoT that has to do with more personal computing than with like general purpose ambient computing. But anyway, concepts like IoT, they're slowly developing, and we never really know where they're going to bring us. And I think that's the real value for it. And I think the real question really is whether we are, as a society, ready to embrace the changes that something as everything connected all the time will bring to us in our everyday life. Because can you imagine that at any time you could know how everything around you is working and how everybody you know are sensing or feeling the world in that very moment? That's a lot of information. And I think those are the kind of challenges that IoT are bringing to the table, and are questions that we can ask ourselves as technology providers, as companies, as entrepreneurs, as researchers, which are the kind of questions that we can solve, the challenges for society, but also the risks that we might bring. So the thing is, the concept isn't new. And the concept of everything connected comes, sorry, I'm about to sneeze, comes already from from a pretty famous text from the 1940s, which is a book called Cybernetics, written by Norbert Wiener. And he speaks about how the commands that we use to like control our environment they're also information, because they're saying in which way we can open up that environment and how we can read information from it, right? So in a sense, having the whole world connected, it also means that it can be controlled through commands, which means that the whole world is programmable, which means basically that we need to rewire our brains, and all of us have to become somehow new programmers that can control this new type of understanding the world. So, but as I said, these concepts are kind of old. There is a lot of research and a lot of academic research done that can influence the future of IoT. We just have to be clever in cherry picking the good things and try to implement them in order to build a better, more connected, more efficient society, right? Well, there is a lot of thinking about the potential risks. And for example, I think at this point, everybody has heard about what the cases have happened about how elections have been influenced through social media, for example. Everybody has heard about personal information being leaked to companies that then start spamming us with like products and phishing attacks and all sorts of other things. So the moment we really start sharing information and our environment starts sharing information, we become very vulnerable because everything we do becomes visible by a huge universe of connected devices and things. So I think it's important to understand this when we think about creating new interactive devices. And the real problem is the speed at which technology grows. It's like, we have better computers all the time. We have better software that does more amazing things. But recently, we're talking a lot about the power of artificial intelligence and the potential dangers. So the speed at which things change is very fast. And we as humans are not really wired to maybe understand these changes this fast. When we're born, it takes us years until we master language. It takes us years until we can really control machines. But a machine is operative from the moment you put the software in it after you have built it. So the speed at which we grow and react is very different from the one that we're building. So we need to really rethink the way we understand speed. And we need to rethink the way we can interact with things. By the way, to the organizers, feel free to cut me at any time because I think my presentation is longer than the material we agreed upon, so that we can have some discussion at some point. Okay. So yeah. So a big discussion for me is a discussion of platforms versus infrastructures. When we talk about IoT, we also have to understand how the world has historically been building new systems. There is two models. I like to call it, and this is, please beware, it's not like a proper terminology I'm going to use now. Okay, I like to call it the American model versus the European model, but this can be discussed. So the American model, in my opinion, is a platform model of building new systems. And the European model is an infrastructure way of doing it. By an infrastructure, I mean a system that is constructed that affects everyday life. For example, the road system, the school system, electricity, running water, the hospitals. In Europe, all of these things are typically created from the government, and then eventually they are privatized. So that's what we call a platformatization of the system. So you create something as an infrastructure, and then it's given away, and then it's handled by other entities. In the States, on the other hand, and that's why we call it the American model, many things were as a platform. For example, when telephony was invented, Graham Bell, through ATT, he got a license to exclusively exploit the use of wire telephony for several years. And so he built this thing, but it wasn't the government that was doing it. It was a company that was doing it, and then built the system. And it's a platform that was operated by himself or his company. And then other people built similar systems and competed against this and so on. And so this is this kind of like private entity system is what I like to call the platform. And so we have these two ways of creating new systems, that coexist. And there's two different ways of doing things. And it's pretty evident that platforms can work in a capitalist economy where there is the rule of competition is the basic rule. But if you come from a welfare philosophy, infrastructures are more important. And there is a representative-based decision on what can be relevant to have, and these things make innovation also work at different speeds in different places. And when it comes to IoT, it's the same thing. So who's going to have the right IoT infrastructure or platform that will gather all of these technologies that will allow us to grow and build new things? So I like to use this as an example. Like, what if we want to bring our kids to start using cutlery, right? And we typically have them to try with these things that aren't really real. Like they learn how to eat with these knife that is made of plastic that doesn't really cut, right? If we really want our kids to start using the right tools to really perform things, they should have a very sharp knife. And of course, it has dangers, right? There is dangers. If you get a 3-year-old kid like a super sharp knife, he will probably have an accident and get cut, right? And we can discuss about how good it is to learn to use tools in different ways. But I mean, clearly, when we teach ourselves, we have this very slow process where we go through the simulation until we go to do the real thing, right? But technology, as I said earlier, doesn't operate like this. Technology is the knife, and eventually it's a laser sword, and it goes much, much faster. I'm going to jump over a couple of slides here. Because I have a lot of discussions about this way of thinking. I here wanted to compare infrastructure and platform. So you see on the left is the internet, and the internet is just one snapshot of the internet. The internet right now, we could call it an infrastructure. Without the internet, our world would not operate the same way it operated 50, 60 years ago. Okay, it really hard to do the things we are doing right now. We couldn't eventually buy anything. I mean, Sweden, we have like no physical currency anymore, really. We pay almost in digital transactions all the time. So without internet, we couldn't pay, so we couldn't buy anything, so we couldn't like eat, for example. We couldn't wear clothes. We couldn't communicate. This lecture wouldn't happen, All you see on the right is how on top of this infrastructure, we build a lot of different platforms. And this is like a collection of platforms, and there's therefore all of those tiny icons that can be used for different things. For example, for pictures, you can see there is Flickr, or for location, there's different types of maps, So you see that there is different types of platforms that can service different things. So the real question here is how these new technologies like IoT are going to be joining this ecosystem. They're obviously going to run on top of the internet infrastructure, right? But then we're going to see new things showing up, and they are already showing up nowadays. But it's still very unclear who are the winners, who are really the ones that are here to stay. So yeah, there's some readings on the topic. And then, because I said I'm one of the co-founders of Arduino, I would like to just very briefly talk to you about what Arduino is, so you can get a bit of a picture of this. So Arduino is a platform, is a technology that is built of software, hardware, and documentation. And it was built in order to help people start using digital technology to build their own artifacts. And by artifact, I mean you could be building a clock to measure how much time it takes to do an operation, or you could be building a laboratory equipment, or you could be building a controller that is part of a larger industrial machine. And in the beginning, Arduino was used mostly by art and design students. When we created it in 2005, our goal was to help art and design students. But as time has gone by, Arduino has become more and more a tool for building Internet of Things devices. So here you can see the most sold product of Arduino is this circuit board. It's called Arduino Uno. And we manufacture about 5,000 of these every day. And they're sold immediately. And you can make the math. You can try to have a picture. We've been selling these products since 2010. Okay, so it's a broadly manufactured device. But on top of that is open source, which means the blueprints that are needed to design, copy, manufacture this device are available on the internet. You can download them and you can make your own. And there exists a plethora, and by plethora I mean tens of different companies in the world that manufacture copies of this device and sell it. So we don't have a clear picture of how many of these devices exist in the world right now. So we like to say that this is the most copied hardware artifact that exists. On top of that, there is a software that is needed to program this circuit board. This circuit board is a tiny computer that can do many operations, but as a tiny computer, it needs tiny software. It's what we call embedded software, right? Because it's embedded inside the actual device. So this software is typically very simple. It has very few commands, but it can do very many things. So the software that is used to program Arduino boards can also be used to program other electronic circuits that are used in the world of IoT. So to give you a picture, this software is downloaded once every 2.5 seconds. So it's very well-used software. It has over 70 million users as of today. And then the important aspect with working with this technology is documentation, because it's an emerging technology, so it's not really clear where it will go. We know it's taking shape slowly as we create it, right? It's like the history of technology is always like this. The more people use it, the better it's shaped. And what happens is that you need documentation to learn about what you can do with it. And in that way, people keep on building new cases, they keep on trying new things and inventing new things. And so this is the Arduino website. You can find it at arduino.cc, and you can see here different projects people are making. And many of them are very creative, like this Pong table is a large interactive coffee table, right? But at the same time, you can read about the Arduino Cloud, which is this service that allows you to document, to have a dashboard online or to see the information of your sensors and your devices. So you could potentially control an Arduino board that you have somewhere connected through the internet by just touching on this graphical user interface. And you could send commands to your Arduino board on distance. So the Arduino community is really large. And these numbers are right now a bit old, I have to tell you. So Arduino has a lot more than 110 million unique visitors a year. It's actually, as it says here, among the 2,000 most visited websites in the world right now. The Arduino forum actually, as of today, has more than 1 million registered users. So this data is a little bit dated. We have over 5 million questions. So it's a very lively development community that is working because the technology is open source. It's available, so people work with it and build new things, but also they help each other building new things. And there's been several companies that emerged out of this community that is built on top of our own company. So it's interesting to see how also the concept of company transforms when you start applying things like open source to it. Like suddenly you don't think anymore about just building technologies and selling them, but also how all people can also build things on top of yourself, because they also enrich your ecosystem and make you live longer, right? You want to have a sustainable model where things can continue to function and you can support the people that are using your technology and so on and so forth. So just to inspire you a little bit, things people can do. Well, people, I think here have a bunch of videos, but because I'm running a bit short, I will not go through everything. So I will just like mention things, and then eventually, when the course, you will see more of this. Okay. So first of all, just to give you an example, many of the is called CubeSats, which is tiny satellites that are the size of like 50 centimeters, so sometimes a little bit larger, that are launched by universities to make research in low orbits. They are built with Arduino compatible technology. For example, the first ever made satellite in Guatemala that was made by Jose Bagura and his group at the Universidad del Valle in Ciudad de Guatemala. It's made using the equivalent to 3 Arduinos in the size of a box the size of this, like it fits in my hands. Right? There is machinery done for like genetic analysis laboratories that is being done with these circuits as well. There is a plethora of open source 3D printers, which firmware is written with Arduino software. There is different sorts of like Bowie controls to detect objects that are in the sea, or measuring the environment and doing like all sorts of like different analysis of like weather information, wind information, and so on. And of course, a lot of home automation. So all of these devices, in one way or the other, contribute to this concept of like a large IoT and connectiveness or connectedness, throughout the whole world. Because more and more of these devices, they empower their use by 1,000 times the moment they can share the information live. For example, you have let's say 3D printer, and you can optimize the usage, because you can get reports on how the print is going or whether the print failed and so on. You can very quickly fix that and improve the outcome of it. While if you basically just let it run and you just disappear, and then you don't know until many hours later that the system, for example, failed. So it's obviously there is very clear and evident advantages of any of these connectivity. Sorry, in any of these cases. Then, of course, I guess I have to show you some projects to brag about what Arduino can do. So this is the first Sony smartwatch ever made. It was launched in 2014, I think. So the moment this Sony smartwatch was launched, we discovered that it has the same chip as one of Arduino boards. So we hacked it and made it run Arduino code. Here you have the proof of that. And so we could just control it. So just to give you the idea that Arduino is hardware, but it's also software. And as software, it could run into any tiny computer, So it just needs some adaptations. And you can include all of the extra aspects of your board into the software. Like, oh, this one has a screen. This one has a temperature sensor. This one has this. And all of those aspects can be added to the software as libraries. And that will allow you to do more things with the software. I think with this, I want to show you this is an old slide, but just to give you an idea how these open source communities can generate business. So I think it's, despite the fact that it's old, I think it's very relevant because it shows how the ecosystem was in 2011. And things haven't changed very much. I think the big difference is in sizes, but also in investment, because we saw how the open source hardware movement in 2011 was emerging. It was starting. Arduino was barely 6 years old. And we already identified this kind of scenario where Arduino is just one tiny piece. So you see up here in the top left, this is Arduino.cc. So Arduino was just this tiny piece that was generated by the Arduino team. And back then we were 5 people. Today, the Arduino company, we are 180 people. And we as company, we don't have any factories. So we design hardware and we collaborate with small factories in the north of Italy. And they manufacture our goods. And these goods are sent to a distribution network. The distribution network here says 178. That's not accurate, right? We have over 400 distributors in the world. And it goes to our community that, again, this picture is from 2011. We don't have 40,000. We have 1 million contributors in our forum as of today, right? So this generates different projects, and this generates a lot of derivative designs that are also manufactured and generates a whole ecosystem of products. For example, 3D printers are based on Arduino, but also clones that generates a gray market of things that go through the market and are used by people. So can you see how generating a system like this one that is open source can actually evolve and grow in many directions? So yeah, with this, I just want to close with reflection about openness. You see, I'm jumping over a lot of stuff because again, this is for a 2 and something hours lecture. So first you have to distinguish the difference between free and open. There is a big discussion in the world of licensing about this. First of all, free comes from the concept of free software. And the idea of free software is that it generates a license that when you apply it to any kind of software, it will force that software to also be free. It's kind of like a viral license. Viral from the concept of virus, like you get infected with that and you carry it and give it to the next, right? And it's a very interesting and very powerful concept that allows people to generate software and share it with the whole world. It doesn't mean that you cannot make money of it, because many of these free software projects are so complex that if you want to make an adaptation, you need to hire the developers to make this adaptation. So the free software license model, business model is consultancy. For example, Red Hat is an example of that, right? And it's a company that does consultancy. Then we have open as a concept, and the idea of open source is that you could actually develop software where you open the source code, but under some conditions, and you are not necessarily forced to make the next version of the software open as well. So you could use it and eventually close it down. And so there's a big controversy in the world of software design because some people say that everything should be open. It's very political. And for that reason, they advocate for the free software license. But other people say, like, no, I mean, it's okay to have some things that are closed. And so these things coexist. And I think there will be a long discussion forever. Then what has happened is that discussion in the world of software has impregnated other areas, like, for example, the world of hardware, where historically we didn't have very many ideas on how to share objects that are hardware-based, because the physical world is different from the software world. The physical world, the objects, they have attached to them legislation that has to do with how they operate and whether they can harm people. So the moment you want to license something openly, you have to be very careful because you don't transfer so you also need to transfer the responsibility. So if I made a hammer and you use my model of the hammer and you use the hammer to hurt somebody, I should not be liable for what you do with the hammer, right? So that's really the idea of the licensing. So the open source hardware license is trying to emulate a mix between the free and the open concepts at the same time, but apply to the physical world. Then in the world of IoT, what's happening is that we still haven't really reached big standards to comes to how things should communicate. Very recently, we saw that Matter, which is a big consortium of communication where companies like, for example, Google are involved, and even IKEA is involved. So they're generating communication mechanisms for that the IoT devices to really work and interoperate, because interoperation between devices is one of the most complicated things. So that will require a whole different way of looking at licensing, where we need to create ways to communicate that are open, but then each one of us as companies will implement it differently, and that might be closed. So what is open is the definition, but not necessarily the implementation. And that brings very interesting discussions as well. Again, there's a bunch of references for this. And so the many people ask us always, like, how do you make money at Arduino? And then, of course, we're discussing a lot on how to make money. At the beginning, we were thinking about using a royalties model where we design these open source devices and then people would pay us for using these designs. We realized that didn't really make sense. So we let people copy the devices, but we sell directly. And we have now a whole system where we manufacture and sell, but we don't own any factories. Then we also have like certification programs for larger and smaller scale. The smaller scale is not called at heart anymore. It has a different name, but doesn't matter. And then we, of course, offer services and consultancy, a lot of educations. By educations, I mean that we have courses for primary, secondary, high school, and university. And then we work a lot of doing exchanges. For example, if, let's say, France is very interested in one of our systems, we collaborate with a company there that will help translating, and in exchange, they will get kits, or they will get money, or or we will together donate the content to the French government. It depends on each situation, right? But working with this openness also opens up or creates opportunities for collaborating in ways that we wouldn't do if we were just a normal business. And yeah, with this, I think I'm going to close. As I said, I have a lot more slides, but I will. Yeah, so I should close with this, with IoT, of course. So how does Arduino contribute to IoT? IoT, as I said, is this ecosystem where we're seeing different manufacturers join, and the idea is that we have different devices that communicate wirelessly to interoperate and then offer us new possibilities and transform the way we understand the world. So what does Arduino do in this whole picture? Well, on the one hand, we manufacture hardware that can be used in many possible ways. We have software that allows reprogramming the circuit boards, and some of the circuit boards can actually be reprogrammed over the air, which means you have a hardware somewhere, and then you send your program to this hardware through Wi-Fi, for example. Then there is a cloud ecosystem where we can send information and we can have a dashboard where we can see the data and so on. And we also have the possibility of manufacturing for other companies, like to say that a car company wants to use some of our sensors inside the car, they can totally pay us, and of course we can manufacture for that. Our vision for this is that we need to, by having different parts open in our ecosystem, we can interoperate with existing devices from many different vendors. Our software can compile for other vendors. Our boards can run in some other people's software, and so on and so forth. So the openness is really a strength in this constantly changing ecosystem of things. And now, yes, I will finish. I'm just trying to find the final slide. But basically, yeah, I wanted to just close now. So we have some time for questions. Thank you so much.
Thank you so much, David. And sorry for before. I assumed that I had some internet problems and I just went on, but it was good. Anyways, thank you very much, David. Now, if any of you attendees have any questions, I'm also gonna, if you want to unmute yourselves, you're more than welcome to talk as well. Thank you, Gergely. Well.
Okay, thank you so much. But
thank you so much, David. Thank you for your time, for everything, for the presentation and everything. And yes, with this, we're wrapping up all the different webinars that we've been doing for the past weeks about all the different MOOC courses that we're offering. So I just want to take the opportunity to put the link here so that you can check out all the courses and you can search for David's course, which you can enroll and enjoy and course for free. You can check his course and many others that we're offering. We invite you to register to the platform. And yes, thank you everybody for attending, and see you next time.
Bye.
Thank you. Bye everyone.